All right, here we are. Starting a little bit early because I want to make sure that we are on time. Welcome, Algebra 2, to our stream. Trying to pull up. We're live. Trying to pull up chat. There we go. We don't have a weird echo. Today, we're going to talk about two things. We're going to talk about turning the fan on first, and then we will talk about sine and cosine. We're going to look at their graphs using some Desmos stuff and graphing by hand, talking about what sine and cosine mean, and then the features of what the graph, like what the vocab is for that. Oh, I forgot to put the plane in. Oh no, it's already in. Never mind. And then we'll talk about grades. I think we'll talk about grades first. But I'm going to turn this fan on. All right. So that's the dog. First thing, grades for seniors are due Friday. So I need your stuff by Friday, before Friday preferably, so that I can get in. I know some people have turned some stuff in and I haven't graded yet. It's my wife's birthday today, so we'll see if I get to it. If not today, then tomorrow for sure. I need to get caught up tomorrow. You're running out of time, like really. Seniors, you're running out of time. You have a lot of time. So I don't know how much sympathy I'm getting. Now, it's weird, it's COVID, but yeah, turn your stuff in, because you should be able to get your grade up. Should have been doing that this whole quarantine. Check your emails, and for everybody, right? Dropbox folder has classwork, homeworks in Atlas, tests and quizzes. Use Khan Academy, and you make it up, right? You make up a study guide, and then you take a test from Khan Academy. Okay? Let's see. So that's that. Now, today we're talking about sine and cosine. I want to first remind us about the unit circle, how sine and cosine work. So we're going to go to here. I want to draw some stuff. And we'll talk about it. Put this camera on. Shoot. Let's do that thing again. It's really laggy. I think it's because my phone is not charged. It's really frustrating. Sorry guys. And hopefully we're there. Yeah? Nope. Instant lag. I don't know what's going on. Well, it is what it is. So, sine, cosine, and tangent. We have so and ka. We're just going to do sine, cosine today. If that's true, if you can find one of the classworks on Dropbox, tell me which one it is. I'll double check. But I'm 100% certain I went through all of them and they're all there. There was an extra credit thing that's not there, but that was extra credit and everything else. So, sine is opposite over hypotenuse. Remember, we're working in the unit circle where the radius is 1. So this is the radius. And we can like draw a triangle in here. And this is going to be 1 then. And sine of the angle is going to be the opposite side over the hypotenuse. And the hypotenuse is 1. So sine of whatever theta is always going to be, the opposite side divided by the hypotenuse. And when this is 1, for the unit circle, it just becomes the opposite side. It becomes the height of this triangle, this O right here. So the value of sine, as this changes in the unit circle, or unit circle, is directly related to how high this is. So depending on the angle, the bigger the angle, the taller it is, right? It's going to max out at 1 here at 90 degrees. Like sine of 90, or pi over 2, we're using radians, it's going to be 1. Because the height. Sine of 0 is 0. So that gives us some starting points for our graph. Okay, and then the last thing, we can go through all of these. We should probably do that. Sine of pi is going to be 0 again. And sine of this is going to be negative. It's going to be down here. Right? Let's give you the height. So this is 1, this is negative 1. Okay? So that's going to give us this curve that sine has. So when we're graphing sine of theta equals y, when we graph this, it's going to look like, starts at 0, goes up to 1, goes back down to 0, goes to negative 1, and so on. It's got this curved shape. These curves aren't super accurate. This is not exactly what it looks like, but it's pretty close. It goes up, and then it goes down. Okay, and so then this happens at pi, this happens at 2 pi, this happens at pi, 3 pi over 2, and then this happens at pi over 2. And this is 1 high, and this is negative. Okay? Because the unit circle is measuring the height of sine as we go around the circle. Okay? So, let's look at this thing in Desmos. Desmos, we're going to go y equals sine x. This screen, that. Here's Desmos. And let's change this. It's we start at 0, right? Like we said. This is at pi over 2, and it's 1 high. And then it goes down, and then it repeats, right? So if I took that chunk, if I graphed at y equals 2 pi, or actually, sorry, x, it would repeat right there. And also x equals 0. So between those two vertical lines, that's the section that repeats over and over and over. Okay. Now cosine is the same thing. It's just shifted over. It starts at 1, goes down and then up, and then down. And yeah, so we'll talk about that in a second. But this is sine. Starts at 0, goes up. It's the height of that triangle on the unit circle as it goes around the unit circle. So the output, the height of the sine wave, so like right here, the height of the sine wave, pi over 2, is 1, which matches with our unit circle height of 1 at 90 degrees, because pi over 2 is 90 degrees. Excuse me. So, we have some vocab, and there should be a list. The student journal looks like this, right? We were going to look at this last week. It's been in the Dropbox for a while now. There's some vocab that we want to talk about right here. Okay, so this is on like the 3rd page of the student journal. So the amplitude is the height of the function. And you can change the amplitude. We can stretch it and we can squish it. Okay, so the height of the function is the amplitude. We're multiplying the function to change the height to be bigger and smaller. So we can squish this function and we can stretch it. So in Desmos, we can change this and we can make it 2, and it's twice as tall now. Or we can make this 20, and it gets really tall. Or we can make it smaller, we can make it 0.5, we can make it -3, and it flips over. Now it's going down. Right, so changing this number in front changes the amplitude. It stretches those sine waves up and down. Okay. Normally the amplitude is 1. Okay. Amplitude, when we're looking at this, is the height. Or it's the multiplier that changes the height of the graph. Yeah. Okay, a periodic function, period being a certain amount of time. How often does this thing repeat? What's the length? How far on the x-axis does it take before the function starts over? Sine and cosine are period. Tangent, they're all periodic functions. They all repeat. The cycle is like how long that takes. The period is the distance that we would measure. So here on our Desmos graph, from 0 to 2 pi, that's the period. That's the distance it is before the graph starts over, 2 pi. And we can shift that. That's not a thing that stays the same. That can change. So the way that we change it is we multiply inside here. We put our number inside where x is, and I multiply, and it multiplies how many things are inside that period. You'll notice it doubled. There's now 2 waves. Right here is now the period. Before it repeats, it goes up and then down. Up, yeah, then down, then back up. And then right there at pi, it starts over. So if I put an x equals pi, this is my new period is half as much. Or because I multiplied by 2. Multiply by 4, and now we have twice as many. We could make it 0.5, and now our curve gets, it still goes the same height. It just kind of looks like it's not as tall, but it's the same height. It's just stretched out. Look, it goes all the way over here before it starts repeating. It doesn't have to be such nice neat numbers here. It could be a third. Let's divide by 3. Oh, sorry. X. So now it's really stretched. Okay, we're dividing. Okay, here's our original. So the period is the distance in between, and that relates to 2 pi. Okay, so the amplitude stretching up and down. Period, how far before our cycle starts over, and then the last thing in our vocab here in our syndrome is this phase shift. This phase shift is how far have I shifted things left and right or up and down. Right, so I can take my sine wave and I can move it around in the coordinate plane, just like any other function. It just doesn't look like it has a center point because it repeats forever on both sides. So there's no there is a center, but it's not really the center because it repeats over and over. Right, if I add 1 here, look, it shifted the graph. It started at 0. It shifted it up 1. So I'm outside. This isn't obvious. We're outside the x. We're outside the sine. Right, I'm taking my whole sine function like this. I'm calculating sine of x, and then I'm adding 1 to it afterwards, and that shifts it up. If we were to subtract, it would go down. Shifts down from my 0 line here. Down 3. Or we can add or subtract inside the function, and we've done this before. Like this has been our whole year, right? Adding in, subtracting inside, adding, subtracting outside. If I add inside, not the right button, plus 2, it moves the graph left and right. So this is a bit hard to figure out, but what it did was it went from 0, it went left to. Remember, adding is subtracting on the inside. If I was to subtract 2, it moves to the right. Okay. Now, Desmos is cool because we can take all these things. We can get rid of all these parentheses. Here's my original function. We can add in a new function, y equals, and there's a special way to write this. Is it in the student journal? I sure hope so. Yeah, this right here. So we've used h and k to talk about our center a lot. A and b here are just multipliers. So we can type this into Desmos, and we get y equals a sine of x dx b here, x minus h plus k. And so when I graph this thing, it doesn't like it. And then we can make those into sliders. And now here's my sine wave, and these all start at 1, so it's not super useful. A should be 1, B should be 1, B should be 0. Okay, so you'll notice it lines up, right? Lines up with my original sine function. Here's the starting point at 0. And we can use these to animate. I think. Where's the photo? Oh, yeah, sorry. All right, so changing the amplitude stretches it and shrinks it. And if it's negative, it flips it over. Basically go back to 0, or to 1, I'm sorry. 0 just makes the function 0. And then B will shrink, squish everything up, or stretch it out. This is the way sound waves work. Sound waves are sine waves, and everything's squished together. It's higher. Yeah, it's complicated. Lower frequencies are further apart. Okay, so this should be at 1 as well. Okay, and then H is inside. When I change this, it shifts it back and forth. So now it's going left, 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 and now it's going right, 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 back to 0. Right. And in K, we can shift it up and down. Right. Up, off K, just going all the way down, and then back down. Okay, so that's a cool thing about Desmos, so we can animate those things. But that's our sine wave. We can make lots of cool things. We can make the, we can make the amplitude really squishy, and we can make it happen more often, and then we could shift it this way a bunch, and shift it up. We can change our sine wave. Now cosine is exactly the same. If I change this to cosine, same thing happens. It looks exactly the same, except cosine is 90 degrees, or pi over 2, shifted from sine. And if I hide this and go back to where just our original, this is sine. If I change this to cosine, at 0 now it's at 1. And we'll talk about y on the unit circle. Okay. All right, so sine and cosine, the graphs are these curves. The amplitude, the distance in between, the amplitude is the height scale, and the period is the distance between the repeats. And for cosine, the reason that the graph starts at 1 is because if we remember SineCosine, this is the adjacent side over the hypotenuse. It's the distance on the x and y. It's left and right distance. So on this circle here, the adjacent side of this triangle is this distance. It starts at 1 when the height is 0 here. When the angle is 0, sorry. So cosine, when the angle is 0, cosine of 0 is 1, right, because it'd be down here. When I go back up to 90, this circle, the triangle moves and moves and moves and moves. It gets to the peak here, up to 90. I have a tangible line. Cosine of pi over 2, 90 degrees, is 0. The left and right distance, if my line is straight up to here, there's no left and right distance, it's 0. And then cosine of pi, 180, back over here, it's -1. Right? This angle, this triangle is going to go over here. Eventually, this meets up on the circle. That's -1. And then down here, it's back to 0 at cosine of pi over 2. Back to 0. And then it would repeat over and over and over. So we get this curve for the value of the angle on the adjacent side. not the height of that triangle, but the left-right move of the triangle. Starts at 1 up here, and goes down, and then up. I drew it kind of weird, but that is which is what we saw in Desmos. Okay, so it starts at 1. Goes on, starts at 1. Those are the main things. The amplitude stretches. The period is how wide the repeat is before it cycles. And I think that's it. The midline. So it talks about this midline. And the vocab is right on this string. So the midline here. That's like the line that goes through the center of the sine or the cosine. It's not really part of the graph, but it'd be 0 here. It'd be this line, this horizontal line that cuts the graph in half. Right? So some things to calculate. You can calculate the amplitude as the absolute value of A. It's going to be negative or positive. The negative or positive flips the graph over. So 2, amplitude 2, negative 2, also an amplitude of 2, but it would flip the graph. The period is going to be 2 pi over whatever B is. That's the distance. That's how far it takes for it to repeat. So that's not going to be the number inside the function. That's 2 pi divided by the number, the absolute value of the number inside the function. So if the number in the function is 2, we divide 2 pi by 2. Now our period is pi. It means we squish things from 2 pi to pi. Okay? And then it wants you to graph these things. So we can graph the original in Desmos on our graphing calculator and see what it looks like, what the difference is. So those are the things. These functions are the same as all the functions we've been doing all semester. So square roots, cubic functions, absolute value functions, they work the same, right? We're shifting left and right, we're scaling up and down, we're squishing, stretching. And those are our sine functions, sine and cosine. Tangent, we'll talk about later on. Those are the basics. Okay, that's it for today. I don't really have like a bunch of examples I want to do. I just want to talk about what the graph looks like. Those keyword, those vocabulary words, amplitude, and the period. We can talk about the music stuff. An amp is called an amp because it changes the amplitude of the sine wave for the sound, like a guitar amp. Big, loud, right? Small, not as loud. Period changes the frequency, which changes the note value. The more squished everything is, the higher it is, the more stretched out, the lower it is. Sometimes stuff is so stretched out you can't even hear it. It's too low. Sometimes it's squished together so much you can't even hear it. It's too high. Okay? And then we can add sine waves together. That's how we get sound on top of sound. That's why and our brains are really good at taking those things apart. Because it's just a math equation. Computers can do it too. But we can just isolate a voice in a crowd, right? We can listen to someone when other people are talking. Because our brains separate out that vocal pattern, the compression wave of air, and it calculates the sound, and we ascribe meaning to that sine wave. It's crazy, right? But sine waves are sound. That's it for today. I think trig functions are really awesome because they're so related to music and sound. But that's it. Hope you guys have a good Tuesday. Remember, senior grades due by Thursday. I want stuff in by Thursday. I'll be grading today and tomorrow. And all week, really. And we'll be back on Thursday. I think we're talking about tangent in the next section. We got like 2 weeks left for everyone who's not a senior, basically. And yeah, good to talk to you. Hope you have a good week. See ya.